So we're going to start chapter 2. Chapter 2 is all about graphs of quadratic functions. So we're going to start by just talking about what is a quadratic function and then what's the parent function. So a quadratic function is anything that has an x squared as its highest exponent. And the most basic quadratic function is the parent function that we have here, just y equals x squared. This is the graph of y equals x squared, and we can graph this without knowing what it looks like by just making a t-chart. Remember, you can always make a graph by picking some values for x and plugging them in to solve for y. So maybe I pick x equals -2. I plug in -2 for x. -2 squared is +4, so that would be this point here on the graph. Then maybe I plug in x equals -1. -1 squared is +1, so that's this point here on the graph. Then I continue, maybe I pick x equals 0. 0 squared is 0, so we have this point here. And maybe I pick +1. +1 squared is 1, so that would be this point here. And maybe I pick 2. 2 squared is 4, so that would be this point here. All quadratic functions are going to have this shape that we see here that we call a parabola. So that parabola is that U shape that's defined by our quadratic functions. One thing to be careful of when we're graphing quadratics is that the larger the numbers you plug in for x, the y values are going to get really large really quickly, or potentially really small if they're negative. The reason being is because you're taking that number and squaring it. So think about if we took a 3, 3 squared is 9. And if we take a 4, 4 squared is 16. So those numbers are just getting bigger and bigger, faster and faster. So typically when we're graphing quadratics and we're picking the x values, we want to stay close to the origin. So we're going to talk today about what we call the vertex form of a quadratic equation, and it is still a quadratic because it still has a x squared. But this equation here where we have y equals a times the quantity x minus h squared plus k is what we call the vertex form. One thing that I want you guys to note is that a, h, and k are all numbers. So your equation is still just going to be in terms of x and y. The h and the k give you some information about the vertex, and the vertex is the point that's either at the very bottom, or sometimes we'll have a parabola that opens down the very top of the parabola. So this point here is called the vertex. So if we have something that's in vertex form, we can find the vertex. We already have one point for our graph right off the bat. In terms of shifting, the h and the k give you information about the shift from the parent function. So the h tells you about the horizontal shift. And then the k tells you about the vertical shift. From the parent function. Let me go ahead and box this off here so we can kind of separate it. Your horizontal shift is always the opposite of the direction you might think, and you'll see what I mean by that in just a minute. So essentially, if you have a minus in here, you think of negative numbers as being to the left, but a minus is actually going to move everything to the right, a certain number of units. And then your vertical shift, this plus here, would move things up, or a minus would move things down. So the vertical shift is in the direction you would think. A is also going to impact the shifting. A has to do with kind of your scale factor, so any stretching or shrinking that's going on. So if A is a number whose absolute value is less than 1, then it's going to make your graph wider than the parent function. If the absolute value is greater than 1, it's going to be more narrow than the parent function. And then the sign of A also tells you if the graph opens up or down. So if you have a positive A, your graph's going to open up like this one here. And if you have a negative A, your graph's going to open down like this one here. So that's kind of a lot in one slide, but we're going to take a look at how it relates to some examples. So we're going to look at an equation, and we're going to talk about how it would be different from the parent function. And then eventually we'll graph it as well. So here's a few examples. Whoops. Here, we're just going to talk about how they shift. So how is it, I got to get back to my pen here. How is it different from the parent function? So let me go ahead and separate my screen. Over here on the left, we can talk about horizontal and vertical shifting. Remember, what's inside of the parentheses is your horizontal shift. That was the H from that general form. And the horizontal shift is always the opposite of the direction you would think. So a +1 actually means we're going to shift to the left 1 unit. Your vertical shift is denoted by this number here outside of the parentheses. And that's going to shift in the direction you would think. So everything here is going to shift down 2 units. And then the last thing to talk about is whether it opens up or down, and then whether it's wider or more narrow than the parent function. And that is determined by this number here, which is A. So here's our A, here's our H, here's our K. So A is positive, which means it's going to open up in the same way that the parent function does. But A is between 0 and 1. So that means that it's actually going to be wider than the parent function. So again, the horizontal shift is given by H, the vertical shift is given by K, information about up or down and wider or more narrow is given by A. So we're going to take a look at the same thing over here. We'll start with the horizontal shift. That's given to us by H, which is inside the parentheses. Again, the opposite of the direction you would think. So a -3 is actually going to be a shift to the right 3. Your vertical shift is given to you by K, and that is in the direction you would think. So a +4 means we're going to shift up 4. And then A is the number in front of the parentheses. So here it's just a negative, which really means it's really a -1. So negative A means that it's going to open down. But then here, this is just really a 1 when we think about the absolute value. So there's going to be no stretching or shrinking because it's going to be the same as the parent function. So just say same width. So now we're going to go ahead and graph these two equations. And then anytime you're going to graph, you can start by graphing the vertex. So your parent function had a vertex at 0, 0. Your new function has a vertex at the point HK, or that horizontal and vertical shift. Once you have that, you can just pick an x value and plug it in to solve for y, and then you're going to reflect it to get a third point because all of these graphs are symmetric. So for this first example over here, we have our vertex at the point HK. So again, this is H, this is K, but H is always the opposite of the direction you would think. So our vertex is actually at -1, -2. Or we can think about it, we said on the previous slide, this is a transformation to the left 1 and down 2. So parent function is at 0, 0, to the left 1 and down 2. We have our vertex at -1, -2. From there, I can just pick an x value and solve to get y. So maybe I pick x equals 0. And you should pick something that's close to your vertex because, again, the further away you get, the bigger those numbers are going to get relatively quickly. So if I pick x equals 0, I'm going to plug that in here to solve for y. And I'll just do that work down here off to the side. I have then y equals 1/2, and then in parentheses 0 plus 1 squared minus 2. So here 0 plus 1, that's a 1. 1 squared is 1. 1 times 1/2 is just 1/2 minus 2. It's going to be negative 1.5 if I want to think about it that way, or negative 1.5. And if you're not really comfortable graphing those decimal values, we could pick a different point, and I'll show you that in just a minute. And then our last spot would be to reflect to get a third point. So these graphs are all symmetrical through this vertical line that passes through the vertex. So we would just reflect that over to the other side. Maybe I got this value and I didn't like it. So maybe I want to pick something else for x. Maybe I pick x equals 1. Okay, so if I plug in x equals 1, I now have y equals that 1/2. It's then 1 plus 1 squared minus 2. So 1 plus 1 is 2. 2 squared is 4. 4 times 1/2 is 2. So 2 minus 2 gives us 0. So I have a point at x equals 1, y equals 0. I could plot that point. And now, here's where I'm symmetrical around. Oops. I need to reflect over that line. So I'm 2 units to the right over here. I would go 2 units to the left over here. And then I would connect to get my graph. Over here, same idea. We have our vertex at the point h, k. So here, again, h always being the opposite of what it looks like in the equation, that would be a positive 3, positive 4. So I could plot that point at positive 3, positive 4. And again, if you just think back to the shifting that we saw in the previous slide, parent function's at 0, 0. We said this graph is shifted to the right 3 and up 4, which puts us right here at our vertex. Again, everything's going to be symmetric around this imaginary line here. So I need to pick an x value and solve for y. So I want to pick something close to this vertex, which had an x value of 3. So maybe I pick x equals 2. I'm going to plug that in here. I get y equals the opposite of 2 minus 3 squared plus 4. So parentheses first, 2 minus 3 is going to be negative 1. Negative 1 squared is positive 1, again, because it's negative 1 times negative 1. So you really want to watch that. If you're going to use your calculator, you want to type it in just as I have it written here. You want parentheses around that negative 1. So that'll become a positive 1. Then we apply the negative. So it'll be a negative 1 plus 4, or 3. So when x is 2, y is 3. So I can go, okay, x is 2, y is 3, and then that gets reflected over to the other side. And so we can see this one is the same width as the parent function, like we had said on the previous slide, but it opens down instead of up. So for your assignment, you have some problems in your book, and the problems in the book are going to do just like we did in the notes. It's going to give you an equation, and then it's going to ask you to describe the transformation. So left, right, up, down, wider or more narrow, and then you're going to sketch the graph.